So let's say you have here gender. Okay. So gender, male, female, 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 male, male, female, male, female, male, female, male, male, female, female. Okay. And this side, let's say you have say qualification, yeah, rating, let's say. Rating, we have three rating: good, very good, poor. So we'll say poor, 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 poor. Then you will say good. And here I say average. Okay.
Yeah.
Okay. See, two variables means we have two columns here. Okay. Male, female, and rating is poor, poor, good, average. Now you tell me, if this data is given to you, what all things can we do? What does this tell you? What you can do here? सोचो कुछ सोचो.
Oh,
Okay. So see, we can create contingency table, जिसको बोलते हैं. How? We create contingency table. Okay. So when you have single variable, we have seen both categorical and we have seen numerical. Categorical mein we took we created frequency table, then we did mean, median, mode. Correct.
yeah.
Now we are focusing on two variables. So frequency table नहीं, इसको बोलते हैं contingency table. So contingency table, you put, let's say, male on one axis and female on another axis. Okay, I can put anyone. Okay, you can put rating here or gender here. और दूसरे को एक रो में डालो. So poor, average, and good. How many values are poor if it is male? Okay, so इसको यूज करते हैं count if in Excel. Count ifs, actually two condition है ना. Count ifs. Okay, criteria, range. Okay, this one. So range is this. Criteria is it should be M. Okay, then criteria is this, and value should be P capital है ना. So male poor is 3, correct? 1, 2, right? Male poor. Now you will D2 को fix कर देते हैं, as this is fixed. This is fixed. Okay, so we'll copy and paste. Okay, we have to change. So these are all male, but this is your average. So this value is, you don't have to worry about Excel, okay? Don't
Yeah.
worry too much about Excel. Excel अपने को नहीं चाहिए. Okay, then here it is. Okay, better I'll copy paste this one. Then I'll go and change to F. To F. To F. Okay, so this is how we will divide the data, okay, into contingency table. Okay, see, when you get into codes, right, advanced level, they'll speak about chi-square test. Okay, so we use chi-square test, but you don't have to know, okay, for now. Okay, you don't have to know for now what is chi-square test. Okay, so इसके बाद, okay, contingency table के बाद, okay, you calculate the number and then you calculate, okay, the proportion of this. Okay, okay, मतलब now I'll copy this here. Okay, total values कितना है इसमें? So for each row you have to calculate total. Sum seven. Okay. $15 है, right? और ये भी 15 होगा. You can do sum here. Okay, so 15. यहाँ पे क्या करते हैं? We'll calculate contribution. Poor male. How many are poor male? 3 by 15. Okay, so L5 we will fix it. And we calculate percentage. Okay, now you have to do for all. Okay, so this is what we create. Okay, this is called contingency table. The contribution madam chal gaya. Okay, so now if you see here, what do you see? Generally, assumption that we'll make is that female gets more poor rating and more average rating. Okay, क्योंकि 26% 20 है. Okay, यहाँ पे एवरेज में भी इसको मेल को सिर्फ 6% है, 13%. Here
Yeah.
most male gets good rating. So female gets most average and poor. See, random number generate किया मैंने. I just randomly generated. This is what it says. Male mostly gets good rating, and female mostly gets poor and average rating. Okay, so this is what you can generate when you have two categorical value. This is very similar to your frequency table, but this is in 2-dimensional. Frequency
Yeah.
table एक ही होता था, यहाँ पे दो है. Okay.
Yeah.
Now tell me, question पूछ रहा हूँ.
Yeah.
Okay, and you can draw a plot also, right? Graph भी बना सकते, bar graph. Now question is, if I pick someone, okay, with poor rating, if I pick someone with poor rating, what is the probability that it is a male? If I pick someone with poor rating, what is the probability that person is male? If I pick someone with poor rating, what is the probability that person is male? If I pick someone with poor rating, matlab, what is open? Poor rating. Correct? तो अगर
Yeah.
that is given is what? Rating is poor. Okay. So poor matlab, you're talking about these 7 people. You're not talking about other 8 people. You're only talking about 7 people. So if I
7.
pick someone with poor rating, okay, so that means you're talking about these 7. What is the probability that person is male? 3/7. Okay. So if you talk,
टोटल नहीं लेने का है क्या?
नहीं टोटल मेल नहीं, मैंने क्वेश्चन क्या बोला, क्वेश्चन पूछा है गिवन दैट इट इज अ रेटिंग इज पुअर, मतलब कि मैंने आई हैव पिक्ड समवन विथ पुअर रेटिंग, आई हैव पिक्ड समवन विथ पुअर रेटिंग। तो मतलब क्या हुआ कि पुअर रेटिंग ओपन है, पुअर रेटिंग गिवन है, पुअर रेटिंग
गिवन.
गिवन है, एंड आई एम नॉट टॉकिंग अबाउट other
टोटल.
these people.
या.
I'm not talking about average or good. I'm talking about
मेल. पुअर.
poor. तो मतलब I'm talking about these 7 people only, correct?
या.
तो आपका डिनोमिनेटर 7 होगी, गिवन जो होता है that is 7. So poor people, poor rating में I can only have 7, correct?
या.
So if I have only 7, okay, what is the probability that it is male? 3/7.
3/.
Okay. Given
Yeah.
that I picked female, what is the probability that female has good rating?
2/5.
क्या?
2/5.
No, I have picked a female. कितने फीमेल है?
8.
हाँ, so given that it's a female, तो डिनोमिनेटर में 8 आएगा,
ओके.
राइट? आपका स्टैटिस्टिक्स नहीं हुआ क्या उसमें, मैथ्स में अभी तक? प्रोबेबिलिटी,
नहीं. नहीं.
प्रोबेबिलिटी, तो अभी क्या कर रहे हो आप वहां पे? नंबर सिस्टम,
या. वीक 1 करा रहे.
वीक 1, ओके। सो गिवन दैट, ओके, टोटल फीमेल, क्योंकि मैंने क्या पूछा, गिवन दैट आई एम टॉकिंग अबाउट फीमेल, तो उसको बोलते हैं कंडीशनल प्रोबेबिलिटी, ओके। आई एम नॉट टॉकिंग अबाउट ऑल द 15, आई एम टॉकिंग अबाउट सबसेट ऑफ 15 female. I'm talking about female. So I'm talking about female, so there are 8 female. What is the probability that if I pick someone from the female, if I pick someone from female, if I pick someone from female, what is the probability that the rating is good? So it is 2/8. कि मैं पहले बोल दे इट्स फीमेल, पहले बोल दे 100% फीमेल, राइट? तो डिनोमिनेटर आपका 8 हो जाएगा, ना कि 15 और 7 और 5, नो, इट विल बी 8 गिवन दैट इज अ फीमेल. What is the probability that rating is good? 2/8. Acha. Now if I ask you, what is the probability that I randomly pick a number and that is female with average 1. Okay, randomly I pick someone. So what is the probability that it is male with average rating? तो यहाँ पे गिवन क्या है, मैं किसके बारे में बात कर रहा हूँ?
ऑल.
ऑल, आई एम टॉकिंग
मेल.
अबाउट ऑल. तो डिनोमिनेटर क्या हो जाएगा?
15.
15 and
मेल एवरेज 1.
हाँ 1, so 1/15. 1/15 is 6.7. ये आपका 6.7 आ जाएगा ये. Okay, so this
Yeah.
is how you will evaluate 2 variables which has categorical relationship between them. Okay, so this is about handling 2 categorical variable. Now we'll talk about 2 numerical variable. ठीक है? So let's say this is temperature and this is, okay, ice cream sales. Temperature and ice cream sales. So if the temperature on that particular day was 25 degrees Celsius, ice cream you sold was 3,100. Okay, then temperature became 29 degree and you sold 5,200 amount of ice cream. Temperature went to 39 degree and you sold, okay, 7,800. Temperature was 26.8 degree and ice cream you sold was okay, 3800. ले टेम्परेचर डाल देता हूँ. Then so let me generate random number between 25 and 38. Okay. Okay. So 35, 32, 27, 29 दो बार आ गया ना, so इसको will make it 27. 27 भी है, 26 will make it 26. Okay. Okay. So 26 है तो it was 4,200. Okay. Then 4,500. Okay. 5,100. Then we'll make it as 3,200. Okay. 4,400. Okay. 4,990. Okay. And we'll make this as 4,600. Okay. So this is highest temperature on that given day. And this is the ice cream sales. So now, do we see any relationship between them or not? Okay. So in this case, you draw what is called as scatter plot.
Scatter plot.
Yes. So go to here, you have charts, go to scatter plot. Okay. So now if you see, this is your scatter plot, right? You see this value, right? In this table, you see that, the values are kind of increasing, right?
Yeah.
Going, so as you increase the temperature, see the relationship that you will see from here. As you increase, or as there is increase in temperature, sales value also increases, right? Okay. Now let's see an example here. So you have, let's say, the time you spend on Facebook. And marks that you get in exam. Okay. So Facebook, you spend 20 hours. Okay. Let me use random between. Three hours to 40 hours. Okay. Now let's say marks. So marks I give, say, 66. Oops, let me fix this value. We'll keep changing. Okay. So you have, say, 66. Okay. You have 45. Okay. You have 49. Okay. You have 70, 65, okay, 25, okay, 31, 22, okay. You get here 39, you get here 88%, you get here 90%, okay. You get here 50%, you get here 55, you get 95, and you get 20 marks. Okay, so let's take another example. Here we have number of hours you spend on Facebook. This is also numerical, and marks that you get. This is also numerical. Now, if I draw this, okay, chart, And you know how to draw chart, right?
Yeah.
How?
So, temperature and time spent on Facebook and then marks.
Correct. So on x-axis, you put, one of the metric. Now, when you go to data science class, you learn that the variable that we know, okay, that we can control is on x-axis. Generally, हम क्या लिखते हैं? Y equal to something x लिखते हैं. So y is what we want to find. See, we can't see. We all want to get 95, 99, 100% marks. Correct? We all want to get 99, 100% marks, but it's not possible to get that. But there are some factors. There are factors using which we can control the marks. Okay. So here you see a factor. The factor is called the number of hours you spend on Facebook. If you know that if you spend more marks on Facebook, you're going to get less marks. So how can you get more marks?
Less time on
Ah,
Facebook.
you spend less time on Facebook, you will get more marks. Okay, if there's a relationship between them. Now, how do you know? You see this data. Here you will see there's a declining trend. There is a
Declining.
so you see there's a declining trend here. So that means if you spend less hours, now you see because marks is we are interested in. Here we are interested in sales. So that's why we'll put sales on y-axis and marks on y-axis. And x-axis means something that we know. Okay, temperature you can predict. You can go to weather.com, you can get the temperature, or what will temperature of Hyderabad tomorrow, day after, you know. But sales you don't know. Sales you want to figure out. So by looking at a parameter which we know, which we can predict, which is easy to get, and if that impacts your y. For example, if I want to know how much sales I'll make and running an ice cream shop, so one factor which I know, which is easy to find and that impacts my business is temperature. तो आपको मालूम करना पड़ेगा क्या factor है जो, see, your objective is to get more sales. So you look through all the factors. What factors? Okay, so one factor which you can find out is the temperature of the day. And then it is easy to get. And if you know, okay, if you find the relationship between them, okay, you can predict your sales. So this is what it shows on the chart. You can see that as temperature increases, your sales also increase. Each point here represents your the hours and the value. Each point here represents the hours on x-axis and sales value on y-axis. Right? Similarly, if you go down here, okay, each point here represents the number of hours you spend on Facebook on x-axis versus marks you get on y-axis. Okay, you can see this data, the points are decreasing. So as you spend more hours on Facebook, your value keeps on decreasing. So there's a downward trend. So we call this as inversely proportional. That means, okay, number of hours you spend on Facebook and marks you get, they are inversely proportional. Proportional. They are inversely proportional, point one. Second point is they are called as negatively correlated. Negatively correlated. Okay. So if they go in opposite direction, if you increase one, other decreases. If you decrease other increases. That means they're going opposite direction. So it is called negatively correlated. They go in same direction. We call it as positive correlation. This is also called as directly proportional. Directly proportional or positively correlated. Okay, positive नहीं आएगा क्योंकि plus doesn't come here. Okay, positively correlated. So now when you find correlation, so we have two factors, so two variables that we have to find out. So this is on the graph. The graph will tell you, but we won't be able to know exact value of correlation. So for that, you need to calculate covariance and correlation. Okay, so that's what we were going to do now. Now let me take one more data and show you. Okay, so now here I take, let's say, number of hours swimming. Swimming hours versus marks you get. Okay, so let's say swimming hours, we will use rand between, and I'm going to say minimum is, let's say 0 to 2 hours per day. So we'll say 15. Okay, and marks you will get between let's say 20 to 90 if I give that. Okay, now we'll create some values here. Okay, I'll control C and I'll do control V. Okay, so now let's see what happens. Do you see any trend here?
No.
Yes,
Yeah.
there is some trend, right? There is some trend. Okay, there is some trend. Now, it is not as positive as this. This is strongly correlated. If you see here, this is weakly correlated. There is trend, right? Here you see these values are higher, correct, than these values. That means if you swim for less hours, you get less mark. So there is some correlation. Okay, but by looking at it, you can say this first one is strongly correlated. But how do we know it is strongly correlated? Okay, that's where we have to go to variance and correlation. Okay, so just give me a second. Covariance formula. Okay, okay. So consider two random variables x and y. We define the covariance between. Variance is on one variable. Remember, yesterday we calculated variance and standard deviation.
Yeah.
Right? Okay. So yesterday we spoke about variance. Variance is on how one value is differing from the mean. That's the variance. Here, all these two variables are different. Okay, so we call as covariance. So covariance, okay, gives information about how x and y are statistically related. Okay, so equation is, okay, E of expected value of, so it is x minus ex into y minus ey into e. Okay, so how do you, okay, so let's look at a value here. Okay, I want to take an example here. This is little higher level. We'll take some numbers and see better, no? Okay, so covariance is measurement of variance between two variables. Variance between two variables. Okay, So variance is where you compare X with its average. Okay, E is expected value or mean. Okay, covariance is X minus, see here, this is better. X minus X bar. This was your variance. Okay, instead of doing square, we will multiply this with Y minus Y bar. Sorry. Okay, we'll continue. Okay, so in variance, ये formula क्या था variance का याद है?
Yeah, sigma square equals to summation of
Mean squared, right? Remember?
yeah,
Mean
yeah,
squared difference. So पहले difference करो, difference is x minus x bar, फिर square करो, then sigma करो, and then divide by n, correct?
yeah.
Here, instead of square, you are multiplying with y, okay? So this is called your covariance, and division वही है. Division, if it is talking about the entire population, descriptive statistics, it is n. If we're talking about sample, it is n minus 1. Okay, so what does covariance tell you? What does covariance tell you? Okay, and correlation is just like, in correlation, you divide by standard deviation. So you bring in standard deviation value also. Okay, so how we do it? Let's go to Excel and calculate. Okay, so we'll look at correlation value here. Okay, or let's do it here. So, okay, I think there is formula covariance sample and P. P is for population, S is for sample. In this case, ours is population, right? Okay, so array 1 is this one, comma, array 2. Okay, so it is minus. Minus y direction. Okay. So see this? This is 271. Okay. Now if I go and perform same thing here, covariance, okay, and you calculate this. Oops, what happened? Covariance dot p. Okay. P is for population. So sorry. First we look at array 1, then we look at array 2. Okay, so you see this value. Okay, now this talks, so this is absolute value. Now tell me, is this better or this better? Which is stronger? Okay, so this tells you relationship between two variables. You there? Yeah.
Yeah, yes, sir.
So yes, so covariance will tell you relationship between two variables. But if I have to compare with overall scheme of things, then we don't know, because higher the value, summation will be bigger only. No.
Yeah.
If I have one more set of values, summation will be big. So covariance does tell you the relationship, but we can't compare whether this is strong. See, okay, this is minus, this is plus. I agree. But is this stronger or this stronger? We don't know. That's why we have to find one more form, one more calculation, which is your correlation. Okay. So covariance tells the relationship between two variables, but within that, it is not possible for us to compare it with other data set. Okay. Which is more stronger? This is more stronger, this is more stronger. So we don't know. So that's why, okay, we divide covariance, okay, with standard deviation. Covariance by standard deviation is your correlation. Okay, so standard deviation we calculated yesterday, remember?
Yeah.
Yes. So standard deviation you can calculate using Excel also. It is STDEV, okay, and this one is, okay, 4.3, and this one is, okay, so now your correlation. Okay, so what we just did is covariance. Okay, so correlation is covariance divided by standard deviation of 1 into standard deviation of another value. Okay, so correlation will always be, okay, will always be between 0 to 1, okay, 0 to -1. Okay, this is for positive correlation. Okay, direct proportional. Inverse, because I can't write plus and minus, that's what I'm writing. So direct, or we say positive correlation. Positive, so minus sign will tell you whether it's positive or negative. Minus sign will tell you whether it is positive or negative. Okay, strong correlation value will always be between 0 to 1 only. Okay, it cannot be more than 1, it cannot be less than -1. Okay, so if you remove the sign, it is between 0 and 1, cannot be, 0 and 1, where closer to 1 indicates it is strongly correlation. Now, if you see here, this is 0.83, correct? Now here you can go and calculate. So we have a formula to calculate correlation also. Correl, it's called Correl. Correl, and you do this, you do this. So see, this is negative, right? Negative means negative correlations going down. That's why negative. But this value is stronger than this one. Now you tell me, for when we calculated standard deviation, we had P and S, right? For population and sample. When we calculated covariance, we had P and S, right? But when we calculate correlation, there is no P and S. Why?
values on 0 say 1.
And -1 will get cancelled. No, it doesn't matter, right? So, okay, so either you calculate standard deviation for population or sample, and then you divide, you get these values. Okay, so now I will share this Excel. Okay, this Excel I'll share with you. I want you to calculate covariance on your own.
Yeah.
Will you do that? And you
Yeah.
can check the value here. So I'm going to say week 4 stats. Okay, I want you, I'll share this. Okay, and you calculate covariance on your own. So covariance will tell you relationship between the two variables. Okay, are they related or not? Sign will tell you are they positively or negatively correlated. Okay, now let's look at this one. Okay, then we'll talk about it. This one we haven't done. So let's directly calculate correlation. So if you say correl and you do this one, you do this one. So you see here, it is 0.48. Okay, so it is plus only. Plus means it is positive correlation. That's why you see values are increasing, right? But it is not as strong. That is 0.8. This is 0.4. So anything less than 0.4, 0.5, we say there is no correlation. We don't worry too much if it is less than 0.5. Only when it is more than 0.7, 0.8, it means there is a correlation. 0.67, we say weak correlation. Okay, so more stronger the correlation, more confident you are about prediction. Now swimming and marks weak correlation, so you cannot control. Okay, should you do swimming or not? Probably yes, but should you spend more time on swimming? No, not required, because that's not impacting your marks. Okay, not you tell me among these. Okay, now you see, should I spend time on Facebook? No, because if you spend, okay, but is it stronger? Yes, 0.9. 0.9 means very strong, right? So, okay, so this is what, the relationship between two variables will tell you. Relationship between two variables will tell you. Okay, now if you move back to our notes, okay, so yes. So covariance will tell you two relationship, but then two relations, it's not enough. Okay, so we go for correlation. Correlation is covariance by, see, covariance is similar to variance, just that instead of square, you are multiplying with y. So you have two variable here, x minus xi sigma, into y minus yi. Yi, xi are the mean of x and y. Okay, multiply and then do summation. Multiply and then do summation. Okay, multiply and then do summation. So I'm going to put this one here so that you know the formula here. So I'm going to put here notes. Okay, so you know from where to take the formula, which link to go. Okay, now correlation also, there are few other types. Okay, so this what we just did. Okay, so this is the entire formula of correlation. Okay, that's why your n square and get cancelled. Okay, and you don't have correlation different for population or sample. Okay, so see here, all the points are on same line. So here correlation is 1, but since the values are decreasing, it is -1. So if you calculate the correlation of this, you'll get -1. Okay, here you see values are decreasing, right? So your correlation is going to be negative. Okay, but not 1, of course. Okay, values are away from this line, so it could be 0.7 kind of. Same thing here, values are increasing, so correlation will be positive, right? But somewhere between 0 and 1. Here, dots are on the same line. Okay, so a correlation is going to be 1. So I can show you this example here. Now let's take another data. Okay. So let's say this is number of hours you study and marks you get. Now let's say if you study for like say, okay, let me generate random number, random between, let's say 5 and 40. Okay. Okay, 5 and 40. Now I will do Control C, paste, Control V. Okay. Let me, 40 will be too much. Okay. 40 is highest, right? Okay. So let's say if you study for 20 hours, you get 40 marks. 29, if you do, you get 58 marks. Okay. 54 marks. 42, 42, 28, 26, 30, 20, okay, 52, 80, and 18. Okay. So now if you draw this scatter plot, you see this? All the dots are in same line.
Yeah.
Right? So if I find a correlation of this, what will I get? Perfect one, positive one. I'll get positive one. So if you want to see, you can say here, correl array 1, comma, array 2. See, it's positive one, exactly one. You got it?
Yeah.
Okay. So if dots are on same line, you get correlation as 1. So this is the maximum. Little bit deviation, your correlation will come down. More the deviation, more it will come down. Okay. Now let's go and go back here. See, dots are everywhere. Low value, see, high value also has low. See, this is high on x-axis, right? High on x-axis is low on y-axis. Here, low on x-axis also has low on y-axis. So it is all, okay, everywhere. Okay. So there is no correlation here. P will be almost 0. Okay. Then there are some difference. Okay. So you have types of correlation. You have Pearson correlation. You have what else you have in your syllabus?
Point by serial.
Pearson point by serial correlation coefficient. Point by serial. Okay. So what you see is Pearson. Pearson is mostly we used. Okay. So where is it? Yeah. Okay. So also known as bivariate correlation. Okay. So bivariate correlation. See, values concept is same. There will be slight change in the formula. Okay. Slight change in the formula. Okay. So this is your Pearson correlation. Now we'll say Pearson correlation versus point by serial. Okay. So this is point by serial. What is different between point by serial and Pearson? Point by serial is a special case of Pearson and used when you want to measure the relationship between a continuous value and a dichotomous variable. So when do we use point by serial?
To measure the relationship between a continuous variable and a dichotomous.
So what is dichotomous? Categorical value. What we've been reading about categorical is your, okay, that is, see, so we have seen numerical versus continuous. Sorry, you have seen categorical versus categorical. We have seen numerical versus numerical, right?
Yeah.
This is when we have one is categorical, one is numeric. So point by serial we'll see tomorrow. Okay, so we'll see
Yeah.
one row, one column is continuous, another column is categorical.
Good.
Then how do you handle it? Make sense?
Yeah.
Okay, so that is called as point by serial. We'll see tomorrow. So today we discussed about two variables,
Category.
right? Tomorrow we'll finish off the other one also. All right.
Yeah.